Heat exchanger final evaluation, Team 9, Angela Grozos.
Thomas Gabriesus.
Mariah Harris.
Our heat exchanger utilizes concentric tubing in a helical shape and operates under counterflow conditions with the hot water going through the copper tube in the opposite direction of the cold water in the PVC tubing. There is convection at both the inside and outside surfaces of the copper tube into the cold water within the PVC and conduction through the walls of the copper tubing. To create our heat exchanger, we placed a copper tube within a PVC plastic tube as well as two PVC T-fittings. Copper was also used for the male ends of the push-to-connect fittings. The thin copper tubing has an outer diameter of 0.5 inches while the PVC plastic tubing has an inner diameter of 1 inch and an outer diameter of 1.25 inches.
After the first evaluation, in order to increase our overall efficiency, we decided to increase the number of coils. To stay within the size constraint, we removed 18 inches of the tube assemble. Once both fittings were removed, we packed sand into the copper and PVC tubing to help prevent any permanent deformation during bending. After we adjusted the bend radius of the heat exchanger, we attached more T-fittings and covered any possible leakage points with waterproof tape and epoxy. It is difficult to compare the two evaluations, as in the first one, the heater was not working properly and could not heat beyond 40 degrees Celsius. Thus, in the first evaluation, the hot water inlet temperature was 39.5 degrees Celsius and the outlet temperature was 30.3 degrees Celsius, whereas the cold water inlet temperature was 22.2 degrees Celsius and the outlet temperature was 27.5 degrees Celsius. In our final evaluation, the hot water inlet temperature was 55 degrees Celsius and the outlet temperature was 34 degrees Celsius, while the cold water inlet temperature was 19 degrees Celsius and the outlet was 29 degrees Celsius. Decreasing the hot water flow rate from 3.4 liters per minute to around 1 liters per minute was a strong contributor in yielding a higher hot water temperature difference.
We first brazed the copper wire at various locations along the copper tubing, and later inserted the copper tube into the PVC plastic tubing. Next, we bent both tubes around a cylindrical surface. Then we packed sand into both the copper and PVC tubing and bent it to a smaller radius. Afterwards, we placed the T-fittings on the inside of the PVC tube, but outside the copper tubing. To secure the fittings, we wrapped several layers of waterproof tape around the copper tubing, as well as epoxy to ensure no leakage. For the future heat transfer lab students, we recommend that they keep shipping times in mind when ordering materials in order to have sufficient amount of time to manufacture before evaluations. We also suggest fully utilizing the expertise of professors by asking for advice on the analysis, material selection, and manufacturing techniques. If we were to recreate this project, we would have focused on buying very cheap materials to initially prototype our design.